Um, we're starting section 2.2, limits and numerical and graphical approach. So we sort of played with the concept of the limit in 2.1, discussing why we need it in this course, or one of the most important reasons that we need it in this course, and that's how it's related to basically how it relates the average rate of change to instantaneous rate of change, basically. So what we discussed in 2.1 in about the limit and short is that when when the distance between A and B it decreases, basically the secant line between A and B on the graph gets closer and closer to something that we call tangent line, and that's the tangent line is sort of the it's what happens when A and B infinitesimally are close, and so the slope of the tangent line becomes the basically it becomes the limit of slope of the secant line, and same thing true when we're discussing the average rate of change, or our average speed. Limit of average speed becomes the instantaneous speed. Now in this section, we define limit a little bit more formally, using two-sided limit and one-sided limit definitions, and then we start estimating limits and giving you more tools on how this limit actually works, basically how to compute the limit, because 2.1 was more an application of the limit and how we use it in this course, one of the ways that we use it in the course. And then 2.2 is more about limits. One-sided limit in this, the notation is limit under with LIM, and underneath you write x to is x right arrow C, and a negative on top of C, which means that from left of f of x is equal to L. And this is the left limit of f, is L if the y value converges to L as x approaches C through values less than C. What is the right limit? Right limit is again lim x right arrow to C and a plus on top of f of x is equal to L, and that is the right limit of f is L if the y values converge to L as x approaches C through values greater than C. It sometimes helps to see how these things are written, and so I start with limit x approaches C from left of function f of x is equal to L if this is satisfied, and the other one is limit of f of x as x approaches C from the right side is equal to L. And so in this is the right limit, right hand side limit, this is the left hand side limit. So we did the right hand side limit, right side limit, and left side limit. What's the two-sided limit? The two-sided limit as x approaches c of f of x is equal to L, that means that the two-sided limit of f is L only if both one-sided limits equal L, basically. So this is an example of a left and right limit. Observe that there's a blue point right here, and blue point is sitting on the graph of the function. Let's try to find how the value of a point changes at x value approaches the point 2 right here, and how the value of the function changes if the x value is approaching 2 from the left side, from the lower values. See, y value is approaching closer and closer to, and then it gets closer and closer to 0, basically. So the left limit as x approaches 2 from left side of f of x is equal to 0. And then, so the next question is, what about the limit as it approaches from the right side? So now I have a red point, and it's basically traveling on the graph, and x is decreasing to get closer and closer to 2. And so you kind of see this, that the right limit actually is the y value for the points, but approaches 4 over here, right there, it's 4. So how does this work, basically? Let's write this down first. Limit as x approaches 2 from the right side of f of x is equal to 4. So this just means that when I was approaching from the left side, let's go back, when I was approaching from the left, the function is creating this path, and the point is traveling on that path as x approaches 2, and then the path is predicting that as x gets to be 2, is the y value is going to be 0. And incidentally, in this case, that prediction matches the value of the function at 2. Here we have basically at a function at 2 is equal to 0. See, at 2 function, this point is part of the function right there, and is equal to 0. And how about the right limit? So the right limit, though, again, the point is traveling on the graph of the function as x is decreasing, and it arrives at this empty spot. So the prediction of the function, that's another way that I'm explaining the limit, the prediction of the function, the prediction that function is doing for the point approaching 2 from the right side actually does not match the value of the function from the right side, but still there is a prediction, and that prediction is 4. So this function is telling that if you're approaching from the right side, you should end up at the value, y value 4 for your function. And so this is something that basically for this function, one prediction from one side is correct, the other prediction is not, but also limit is that prediction. So limit exists, a limit from left and limit from right both of them exist, except that there are predictions, and that those prediction in one way is correct, the other way is not. And that's so the predictions exist, but then the value may not match the prediction, basically. And so if like, imagine if the point was traveling on this side and it would end up here, so the prediction would match. And if the point was so at x equal to 1 over here, actually predictions, both sides match the value of the function. So if I had the y value, let's see, approaching over here, we're approaching negative 0.5 right there. The function is seeing that the value of the function at point -5 is about -2.5, and the value of the function is that, basically. So the prediction, if the function was the graph of a function was a path, that limit tells you the prediction on traveling on those paths. And then there's a value of the function that is there. They're different issues, and they're not dependent of each other, unless extra information, extra restriction is given. So now, example 1, another example, identifying limits on a graph. Discuss the limits and actual value on the following graph. Identifying limit on a graph, example 1. So we would like to discuss the limit and actual value on the following graph, basically. So observe that we again use this x value, and the point with x value that is approaching from the left side to 1, and then another point with x value that is approaching from the right side to 1. So let's see what happens. As x approaches from left side, y value, see the y values are getting closer and closer to 1. And as x approaches from the right side, the y values are approaching 0. Look at this. The prediction that the function is making for the point, if it's approaching from left, does not match the value of the function here. But no matter what, there is a prediction. And then the prediction from the right actually matches the value of the function over here. So what about x equal to 2? As points, and the x value of the points approaches 2 from left or right, you can see that the y value for both of them approaches 1. And incidentally, the value of the function at 2 is also 1. So in this case, basically, you will get limit as x approaches 2 from the negative side, from left side, is equal to the limit of the function as x approaches 2 from the right side, and that value is 1, and that is actually equal to f of 2 itself. So this is the case for this part of the function. So the prediction from left, prediction from the right matches the value of the function. Now how about x equal to 3? As x approaches x equal to 3 from left or from right, y values approach 0. So in this case, the limits are both equal to each other. So the limit as x approaches 3 from left of the function of y value is equal to both prediction from the left and right are saying that the value is supposed to be 0, but that is not equal to the function value, because function value at 3 is equal to 1. Again, we wrote this one down. Also, over here was limit of f of x as x approaches 1 from negative side was equal to 1. And this was not equal to limit the prediction from the right side equal to 0. But the prediction from the right side was equal to the value of the function at 1 over here. Let's do another example. In here, first, let's see. It seems that if there's no breakage in the function or no jump, then the prediction from left and prediction from the right matches the value of the function, and it's all the same thing, so it's equal to the value of the function at this point. We're kind of following that. So if there is no breakage in here, everywhere on this function, if there's no breakage, the value of the functions are gonna match the basically the limits. So for example, limit of f of x either from right or left, so I can actually write from limit as x approaches 2, so either right or left are the same, and so the y value that we get at x equal to 2, which is 1.8, I think, is the limit. But how about where there are breakage, like this point? How about over here where something y value goes to infinity? There's a vertical asymptote there, and over here and over here. So let's discuss those. So first, for x equal to 0. For x equal to 0, you see that there's no value for the function on the left side, so there's only on the right side, and that y value is approaching 5, so the prediction of the function is 5 for the y value as x approaches 0. And that incidentally, see, there's a full point in there, therefore f of 0 also is equal to 5. Now how about x equal to 3, which is another breakage? As x approaches 3 from the left side, limit of f of x is equal to negative infinity, goes toward the negative infinity. As it approaches from the right side, the limit of f of x approaches 4, basically. See, the y value for f of x as x approaches 3 from right side is equal to 4, and that's actually equal to value of f of 3. So the prediction of the road that ends to x equal to 3 is the same as the value at x equal to 3. So, and then again over here, the limit of f of x as x approaches 5 from the left is equal to 2, equal to the value of the function right there, basically. But how about limit as x approaches 5 from the right side? That's equal to negative 3 and is not equal to, so this whole is not the same y value as the value of the function, obviously. That means that the limit from the right is different from limit from the left. And so what about at x equal to 6? On both sides the limits go to infinities, and suddenly here we don't have a value for value of function for x equal to 6. Remember, this is a vertical asymptote, and here at x equal to 6 and x equal to 3, there are two vertical asymptotes. We do have a value for function at 3. We don't have a value for function at 6. So you can have vertical asymptote and have a value for the function at 6 at that point, basically. We could have put a point right here, for example, and then that would be the value of the function for, let's say I could have added a point right there, and then the value of f at 6 would have been equal to 1 with vertical asymptote that goes both sides. Basically, it still would work with the value of the function. But value of the function when there are vertical asymptotes is not going to be equal to at least one of the left-sided or right-sided limit. And the last one, at x equal to 8, we don't have any right side limit, we only have a left side limit, and that is equal to basically in here you can see the x as x approaches 8 from the left side, you will end up the function ends up to be equal to -1, which is the value of the function at 8 also. Okay, so from all these discussions that we had, limit doesn't exist at 0, limit doesn't exist at 3, limit doesn't exist at 5, or limit doesn't exist at 6 or 8. And why? Because the left side limit and right side limit were not equal. And then the other thing is that if I say the limit is equal to infinity, that means the limit doesn't exist. And so even at 6, limit doesn't exist because limit equal to infinity means that it doesn't exist. That means that the limit is infinite and doesn't exist. So that's the definition that we're going to use. Now let's do an iClicker question 2.